Imagine you are scheduling a meeting with your teammate. You say tomorrow at 10 a.m. Sounds simple, right? But what if your teammate is in New York, you are in Mumbai, and daylight savings just kicked in? Suddenly, tomorrow at 10 a.m. could mean two very different things. Computers face the same problem when dealing with date and time. Before Java 8, we had to use classes like date and calendar to work with date and time. And these classes had many problems. For example, these classes are mutable, which could lead to sneaky bug. The design is very confusing, like months starts from 0, while days and years start from 1. Some of the classes in this API were not thread safe, which means if you use it in multi-threaded environment, your code could break. The API naming is also very poor. For example, date represents both date and time. Calendar is bloated and intent is never clear. Finally, with Java 8, we got the new date and time API. This API gives us a very clean, powerful way to work with time. The API has very logical design. This is the reason it is very consistent and easy to reason about. The classes are immutable and thread safe, which means there are no surprises in concurrency. There is a clear separation between machine time, human time, and zone time. The API is inspired by java.time, but built into the JDK from Java 8. Now let's dive in and see how it solves problems that once drove Java developers crazy. Now let's look at first class from this new java.time API. From a machine point of view, the most natural format to model time is a number on a continuous timeline. In Java, instant is a point on that timeline. This timeline begins at arbitrary January 1, 1970 UTC midnight. This point is also called as epoch. Now, the instant is seconds plus nanoseconds from this epoch. In Java, you can create instant easily by using this API instant.now. There are various use cases for using the instant. Like if you are logging events, you are storing timestamp in databases, you are synchronizing time across distributed systems, or you are doing a benchmarking. Now I will go into detail with all these examples in a separate video, and we will see all the use cases of instance there. For now, just remember instant equal to machine timestamp. Now from machine time, let's move to the human time. Java 8 introduced a new API called LocalDate. Do you really need to store time when you are tracking someone's birthday? No, right? Old Java Date API included both date time zone, which was confusing when you only needed part of it. So this local date is a date without time or time zone. It only contains year, month, and day. Think of it as a day on a calendar. You can use these APIs to create local date. We will go in a detail in a separate video for human time. Use cases for local date are birthdays, holidays, due date, where you only need a day and not any time. The next API is a local time. Similarly, do you need a date when you are setting an alarm for 7 a.m. every day? No, right? So local time represents a time of the day without date or time zone. It contains hour, minute, and second. There are similar ways to create a local time instance in Java. And use cases for these are, say, alarm, lunchtime, or office hours, which doesn't need any day information. We can combine date and time as well. So whenever we need both date and time, say I need to schedule a meeting on say particular day with some another person in the local time, then I can use the local date and time API. Time without a time zone is meaningless when working globally. Remember our original problem? You in Mumbai, your teammate in New York. If we only use local date time, we are ignoring time zones, and that could mean very different moments. That is where zone date time comes into picture. It is combination of local date time plus zone ID. In our example that we saw, we could have set now the local date and local time for the meeting, which is 10 a.m. And we can add zone ID of New York to create a zone date time. Now, use cases for time with time zones are flight departures and arrival, setting online meetings across time zones, financial transaction, stock trading, also global logging and audit trades. So that is the big picture of the Java data and time API, why it was introduced and how it is structured. Now we know machine time, which is an instant that represents a point in a timeline. Then we also know the human time, which contains local date, and you can think of it as a day on a calendar. Then there is a local time, which you can think of as a clock. Then there is a local date time, which combines both calendar and the time. Then there is a zone date time, which combines calendar plus clock plus a place on Earth. In the next videos, I will take you deeper into each of these with practical code examples. This way, you will not just know what classes exist, but also when to use which. If you found this overview useful, make sure to check out the next video where we will start with instant and see it in action.